By looking at this picture, we'll all get a very simple question. And the question is, how high is this helicopter and how deep is the submarine? Now to answer this question, we need a reference line, correct? So what is that reference line we are taking here? That is nothing but the sea level. So here if you see, we have 0 exactly at the sea level, and if you consider one unit to be as 100 meters, then the helicopter is at around 300 meters above the sea level, correct? And the submarine is at 150 meters deep below the sea level. Very similarly, students, I'll give you another example. The two famous cities in India. One is Chennai, whose height is 6.7 meters above the sea level, and another is Bengaluru, whose height is 900 meters above the sea level. So what are we trying to tell here is, we are considering the mean sea level as the reference line, or we also call it as datum, which is considered as a reference line. With respect to that, we will be telling what is the height of a particular city or any object which is flying in the air or any object which is beneath the water. Understanding? So this is considered as 0, plus 1, plus 2, plus 3. Very similarly, minus 1, minus 2, minus 3, and it goes on. Welcome to Vista's Learning. This is Karthik, your maths tutor. This brings me to the concept of integers. So what are integers, students? Integers is nothing but a set of numbers. So what is integers? Integers is represented first of all by a capital letter called as I. So what is integers? Integers is nothing but a set of numbers. So I is equal to minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3 until infinity. So this set of numbers is called as integers, which is consisting of both negative as well as positive numbers. Integers is also including the natural numbers, which are the counting numbers, as well as the whole numbers, which includes the number called as 0. So this will be our today's topic. So what are we going to study in this topic, students? So in this topic, we are going to study what is additive inverse and what is the basic operations on integers. When I tell what is basic operations, here basic operations is referring to addition, subtraction, multiplication and division. So we'll see the very first point, what is the additive inverse? Additive inverse is a number on which getting added to the original number results into a 0. So for example, we have a number here, 10. So we have to add a number here such that the answer is 0. So what is that number? That number is inverse of this, right? So this is plus 10, correct? So here what we have to write? In the bracket we have to write it is minus 10. So plus 10 minus 10 will give us how much? 0. So minus 10 is the additive inverse of 10. Moving on, so for examples, the additive inverse of plus 8 is minus 8. So you add them both, what will be the answer? 0. Very similarly, the additive inverse of minus 3. So here if you see it is positive 8 and here we are writing it as negative 8. So here it is negative 3, we are writing it as what? Positive 3 is the additive inverse of minus 3. Moving on to the next one, the basic operations on integers. So which means what? The basic operation on integers, that is nothing but addition of integers, subtraction of integers, multiplication of integers as well as division of integers. The very first one we'll see, that is addition of integers. Under addition of integers, there are 4 things which you have to remember. So what are those 4 things? We'll see one by one. The very first one is closure property. So what do you mean by closure property? See the definition here. Closure property holds good for addition of integers. So they are telling just closure property holds good for addition of integers, which means, for example, 4 plus 8. So any 2 integers if you add, the result is also belonging to an integer. So then we call it as what? Closure property holds good for addition of integers. Moving on, the next one is associative property. So under associative property, again what is happening here? Associative property holds good for addition of integers. Again this is holding good for addition of integers. So for example, 4 plus of 1 plus 2 is equal to 4 plus 1 of plus 2. So if you add on both the sides, you are getting the answer as 7. So LHS equals RHS, right? So associative property holds good for addition. Moving on to the next one, here we have the commutative property. So again, commutative property holds good for addition of integers. So for example, again, 3 plus 6 is equal to 6 plus 3. LHS equals RHS, correct? So again, closure commutative property holds good for addition of integers. Moving to the next one, additive identity. So what is additive identity? Additive identity is a number on which being added to the original number results into a original number. So for example, so a number when added to any number results the same number, the same thing what I said. So for example, you take a number, let us take 45, add 0 to it, what is the answer? 45 is the answer. So what is the additive identity here? The additive identity is nothing but 0. So this is addition of integers and properties of additions of integers. Moving on to the next one, the next basic operation, that is nothing but subtraction of integers. So under subtraction of integers we have 3 points. So we'll see what are those points again. The very first one, closure property. So closure property holds good for subtraction of integers, which means what? When you subtract two integers, whatever the result you obtain is also belonging to an integer. So for example, 3 minus 9 is equal to minus 6 and minus 6 is belonging to integers, therefore closure property is holding good for subtraction of integers. The next one we'll see, associative property. So here it is, associative property does not holds good for subtraction of integers. So for example, if you take 4 minus of 3 minus 1 is not equal to 4 minus 3 of minus 1. So since it is not equal to, what are we writing? It does not holds good for subtraction of integers. Next one, commutative property. So commutative property also does not holds good, correct? So commutative property also does not holds good for the subtraction of integers. How can we tell that? By taking an example again. So the example here is 3 minus 6 is equal to minus 3. So LHS you see, minus 3 we are getting. And if you reverse the digits there, 6 minus 3 is equal to plus 3. Again, these both are not equal, right? These both are not equal to each other. That is the reason commutative property does not holds good for subtraction of integers. Understanding? Moving on to the next point. The next basic operation, that is nothing but multiplication of integers. So under multiplication of integers, we have again 4 different points. So the very first point is closure law holds good for multiplication of integers. So what is closure law again? When you multiply two integers, whatever the result we are getting, that must be belonging to an integer. If it is belonging, then closure law holds good for multiplication. Alright. The next one we'll see. The next is commutative law also holds good for multiplication. So for example, here we have taken 4 into minus 3 is minus 12. So LHS we got it as minus 12. Similarly, minus 3 into 4 also we are getting it as minus 12, right? So LHS equals RHS. So therefore commutative law holds good for multiplication of integers. The next one, associative property holds good for multiplication. So again, for example, 3 into 2 into 4 will give us 24. Very similarly, 3 into 2 into 4 will again give us how much? 24. So LHS equals RHS. So what is getting difference here, students? The brackets. So whatever is coming within the brackets, you have to solve that first. So here if you solve it is 8, here if you solve it is 6, 3 8s are 24, 6 4s are 24. So therefore, associative law holds good for multiplication of integers. Moving on to the next one, distributive of multiplication over addition also holds good, which means 10 into 6 plus 2, 10 into 6 plus 10 into 2. So the LHS will be equal to RHS. Therefore, the distributive law over addition for the multiplication of integers also holds good. So this is about multiplication of integers. So there are 3 more points under multiplication of integers. We'll see the next one. This is very important, by the way. So here what are we seeing? This is a small table which you have to remember. To remember this table, it's very simple, students. Let me explain. So what you have to do here is, whenever the signs are same, so here the signs are same, right? Correct? Here also you see the signs are same. Always remember this thing. Whenever the signs are same, the answer will be sum. S-U-M. That is nothing but addition. S-U-M. Just look out for the same signs. If the signs are same, then what will be the answer? The answer will be sum. On the other hand, if the signs are different, so here it is plus, here we have minus, the signs are different, right? Here also you see in the next one, here it is minus, here it is plus, again the signs are different. So whenever the signs are different under multiplication, what will be the answer? The answer will be difference only. So difference is nothing but what? Subtraction. So difference is nothing but subtraction. So pretty easy, right? Whenever the signs are same, plus plus, minus minus, whenever it is same, what is the answer? Sum. That is nothing but plus. Whenever the signs are different, what is the answer? The answer is difference. That is nothing but subtraction. The next property of multiplication, multiplicative identity. So just now we have seen what is additive identity, right? If you can recall what is additive identity is a number on adding to an original number results in the same number. So for example, 0 is an additive identity. In the very similar manner, we have a multiplicative identity also, which means multiplicative identity is a number on multiplying to the original number, we are getting the same number. So for example, we'll take 323 into 1 will give us how much? 323. Another example, 23 into 1 will give us how much? 23. So what can you observe here? 1 is nothing but called as the multiplicative identity in multiplication. So this is the point to be remembered. The next one. Any number multiplied with 0 results in 0, no matter small number or big number. So let us take 0.1 into 0, or we can also take 999 into 0. So in both the cases, the answer will be equal to 0. So this is one of the property of multiplication with integers. So this table is very important, very easy to remember as well. Whenever you get same signs, you'll get sum. Whenever you get different signs, you'll be getting difference. Moving on to the next operation of integers, that is nothing but division of integers. So what is happening in division of integers? We have seen this, right? For multiplication, if it is same, the answer is sum. If it is different, the answer is difference. You have to just replace the multiplication sign with the division sign. The same thing holds good for division as well. So whenever it is same, the answer is sum. Whenever it is different, the answer is difference. Okay, students. So this is what is entirely covered in your integers chapter. At the last, we have a very quick summary. What are we going to see here? Whatever we have studied until now. So this is a mind map. So you can take a screenshot of this. Okay, this is what we have basically learned, and this is what is there in the integers chapter. All right. So coming here, what is integers? Integers is nothing but natural numbers plus whole numbers. It also includes the negative numbers. All right. So what are the basic operations of integers? Addition, subtraction, multiplication, and division. So what did we see in addition? Additive identity, additive inverse, closure law holds good, associative law holds good, commutative law holds good for addition. You see, for subtraction, only the closure law holds good for subtraction. Understanding? So here in multiplication, we saw the closure law is holding good, commutative law, associative law, distributive law, multiplicative identity, and the table, which is very, very important. So this is what we have seen under multiplication. At the last, in division, we have seen the table, so which is this nothing but the same thing which we have seen in multiplication. The only change is the sign is getting changed. Understood? So at last, to get more content of mathematics in such a manner, in such a beautiful mind maps and all, you have to log into our web application, which is www.v-learning.in, or you can also download our Android application, Vista's Learning. So this is the end of the chapter. Stay connected with Vista's Learning. I'll be seeing you in the next chapter again. Thank you.